A sharp stone, a dinosaur. It looks like proof, but it proves almost nothing. Could a non-avian dinosaur actually use an object as a tool? Not just touch it, use it. The difference matters. A stone lying near a skeleton can create a powerful image, but a powerful image is not evidence. By the end of this video, you will know what a convincing case would need, why living animals matter, and why the fossil record still cannot give us a simple yes or no. Researchers often distinguish simple object interaction from tool use, but the boundary is not always perfectly sharp. An animal may move, carry, or touch an object without using it as a tool. A bird can pick up a twig. A lizard can shove a pebble out of its burrow. Those actions alone tell us very little. Tool use is more specific. It means using a controlled external object to produce an effect, extend reach, or test something in the environment. Tool making goes one step further, shaping or assembling an object so it works better. A chimpanzee stripping leaves from a stick before using it to fish for termites is a familiar example. So where would a dinosaur fit? A sharp rock near a dinosaur skeleton could be a tool. It could also be a rock that simply happened to land there. Nature creates sharp edges without any animal involved. Frost can crack stone. One rock falling onto another can make a sharp fragment just as easily as a claw could. Before a stone becomes evidence of tool use, two things have to be connected: a deliberate animal action and a physical result. Without both, the story may be interesting, but it is still only a story. If any non-avian dinosaur used a tool, small, sharp-clawed theropods would be among the most reasonable candidates. Their hands and forelimbs could have been useful for gripping or manipulating small objects. Some troodontid theropods also had relatively large brains and strong sensory anatomy compared with many other dinosaurs. Popular discussions often mention troodon in this context. But the important point is not one famous dinosaur name. It is the general anatomy. Researchers sometimes use an encephalization quotient, or EQ, to estimate how large an animal's brain was relative to its body. EQ is an indirect measurement of relative brain size. It cannot tell us whether the animal actually used tools. Think of it like computer hardware. A larger brain may suggest more processing capacity, but hardware does not tell us what the animal did with it. Nothing in a bone alone can reveal what that brain or that hand did on one afternoon millions of years ago. This is why dramatic headlines go too far. Useful anatomy creates a possibility. It does not record behavior. Dinosaurs are extinct, but some of their closest living relatives are still here. According to current scientific classification, birds and crocodilians are the nearest living groups to dinosaurs. Modern animals cannot prove what an extinct dinosaur did, but they can show that tool-like behavior is biologically possible in more than one kind of animal. Some herons drop bait onto the water to lure fish close enough to strike. Some crows bend and shape sticks into hooks to pull food from narrow spaces. Egyptian vultures have been observed using stones to break open hard ostrich eggs. Together, these examples show three different functions: triggering a reaction, improving an object, and overcoming a physical barrier. But these animals are not time machines. A crow using a hook today is not a fossil discovery about a dinosaur. It is a comparison. It tells us that tool-like behavior can evolve in animals with very different bodies and brains. It does not tell us that a particular dinosaur actually did it. So what would direct evidence look like? 4 lines of evidence would make the case much stronger. First, control. The animal must have deliberately picked up, positioned, or manipulated the object, not simply bumped into it. Second, a target effect. The object must clearly help achieve something specific, such as breaking a shell, reaching food, or moving material. Third, repeated context. The same kind of action should appear more than once, preferably in a pattern that is difficult to explain as an accident. Fourth, matching wear. Microscopic marks on the object or target should fit repeated use, rather than erosion, transport, sediment pressure, or damage from another animal. One clue by itself proves very little. A stone near a claw could be coincidence. A scratch could come from the environment. Even a damaged shell could have broken naturally. Now imagine a much stronger discovery. A fossilized nest contains broken eggs. Beside those eggs are several stones. The stones show matching microscopic damage, and the damage fits the position and movement of the dinosaur's claws. the same pattern appears at more than one nest. That would be a compelling case. Researchers would still test alternative explanations, but the evidence would finally connect an animal, an object, a target, and a repeated action in one place. No widely accepted direct fossil case is currently known to show that complete chain for non-avian dinosaur tool use. Here is the harder problem, and it is not necessarily about dinosaurs being unintelligent. It is about preservation. Fossils most often preserve hard parts, bones, teeth, shells, and sometimes durable traces. The behavior itself is rarely preserved directly. But tracks, nests, burrows, feeding marks, and coprolites can preserve parts of what an animal did. Even so, most everyday actions leave no durable record. A dinosaur could have picked up a stone, used it once, and dropped it without leaving anything that would survive millions of years. The object might be moved by water. The nest might be destroyed. The bones might never be buried. The behavior might disappear without a trace. And even when a wear pattern survives, nature creates confusing evidence. Erosion can scratch a surface. Sediment can grind against it. Another animal can damage it. Researchers must separate deliberate use from every natural process that could create a similar mark. That means the fossil record is not telling us that dinosaurs definitely did not use tools. It is telling us that the evidence is extremely difficult to preserve and even harder to identify with confidence. Maybe the behavior never happened, or maybe it happened but the evidence vanished. That gap is where this mystery lives for courtship, play, communication, and other brief behaviors too. Let us score the evidence honestly, not as an intelligence score but as an evidence status. Anatomy indirect support. Some small theropods had hands and bodies that could have allowed object manipulation. Behavior unknown. Fossils do not show what a particular dinosaur consciously intended to do. Control unconfirmed. No widely accepted fossil currently shows a dinosaur deliberately holding an object during a specific action. Matching wear and target effect unconfirmed. No accepted case connects a dinosaur, an object, a target, and repeated use with enough certainty. That is not a dinosaur Stone Age. It is a plausible question with no direct fossil proof. Tool use is not a simple ladder with humans at the top and every other animal at the bottom. Similar behaviors have appeared in different branches of the animal world. If a dinosaur fossil revealed deliberate tool use, it would push the history of that behavior farther back. If no fossil appears, that would not prove impossibility. The evidence may simply not have survived. So did any dinosaur ever hold a tool? The most careful answer is possible in principle but unproven in the fossil record. Some dinosaurs had anatomy that may have allowed object manipulation. Living animals show that tool-like behavior can evolve outside humans and outside mammals. But no widely accepted fossil discovery has yet demonstrated deliberate control, a clear target effect, repeated context, and matching wear all together. The stone from the opening shot is still just a stone. It becomes evidence only when the surrounding context shows what happened to it and who caused it. The door is open, but nothing has walked through it yet. That is scientific caution, respecting what the evidence can support without turning possibility into fact. If you want to see how close dinosaurs may have come to a Stone Age, watch our next investigation. We will separate what fossils show from what imagination adds.